least it was to me, that I was just an undergraduate and I applied to graduate school and I'm going to be teaching undergraduates. I didn't seem to understand that too well. So there's something called GSI training that happens at the University of Michigan. This is probably in all programs, where a few weeks before school, they teach you how to hold a discussion, they teach you how to teach a lab, and how to grade papers, how to enter them into a grade book. So they prepare you for all of the unexpected. When you enter in, you're either going to be teaching a lab, or you're going to be teaching you'll be teaching a discussion. So a discussion is once the professor lectures, the students are usually all confused, then they come to you and you help them sort through everything that the professor said. And your teaching commitment is around 20 hours a week, which isn't really true at all. They say 20 hours a week. I think I work 6 hours a week, but that depends. So I was a discussion person. Some people who teach labs. The labs, I think, they have to teach 2 labs for 4 hours. So that's 8 hours a week plus grading. So teaching labs, you get the bum deal, but I taught discussions. And classes. So classes are not very traditional. So you take 4 classes that are specific for your division. So I took organic chemistry classes. In addition, we have to take 2 classes that are outside of the department. But grades aren't normal. So the lowest grade that you'll ever get is a B, and that's okay. My friend got a 30 or 40% on a test, and they're like, oh my god, I failed, I'm done, and I think they got a B plus in the course. So the classes are there to break you down, but in the end you get built up because you don't fail. So graduate research. So as I said, I firmly joined the Wolf Lab May 1st of 2008, so here's a picture of my lab. And I work in the lab all day with 10 other graduate students. And so graduate school isn't for the light of heart, so I work sometimes 55, 65 hours a week, but it's unique in that you don't set, no one is there watching you punching a clock. You set your own hours, so I can work as little as I wanted, but at the end of the week, I need to be happy with the research progress that I've made. I have 2 group meetings a week, both formal and informal. So the formal one, someone in the group presents their research over a few months span to the rest of our group. And then an informal one is a weekly meeting that we have where we talk about our weekly progress that we've had in the lab. You help write papers and grants. So remember, grants are what funds the lab. So grants to the government agencies you have to write. And present research at conferences. Last summer, I went to Boulder, Colorado, and I presented my research. That was another free trip. Okay. And I got to meet a bunch of cool grad students. I got to see a bunch of really awesome chemistry speakers. I got to hike in the mountains. It was pretty good. And also doing graduate research, you get to meet a lot of professors from other universities. So soon I'm going to be applying to postdocs, and so it's good to make these connections with other professors. But as I said, it's very similar to a job. So at the end of the week, I need to be happy with the progress I made. If I took a 2-hour lunch on Monday, I might need to make up for it on Friday by working a little bit longer. But overall, you set your own hours, and it's pretty great. So the research that I do now is that we make biologically relevant molecules that could help cure diseases. And so like when I talk make two different substrates and make one product, which I'll go into later. But metals can serve as an artificial enzyme. So transition metals such as palladium, rhodium, iridium, you name it, they can all kind of serve as enzymes in that they can form multiple bonds in one pod without carrying out several different organic reactions at once. So palladium catalysis, here's what I was talking about, where I want to take two different starting materials and combine them to make one. So here I take this molecule and this molecule, and I combine it to make this molecule shown here. The lines formed, the bonds in blue are the bonds that are made by the palladium catalyst. And so since it is a catalyst and since you regenerate it, you only need a small amount. So for every one equivalent of this molecule and this molecule, I only need 0.01 equivalents of palladium. So I don't need a stoichiometric amount of palladium to make these reactions go. And the reactions are done under an inert atmosphere as well. So here I just want to show you how you can take relatively simple molecules, make them look more complex. So here, starting off with bromobenzene and a variety of different starting materials, you can make these molecules where the lines in blue are the ones that the palladium, the bonds of the palladium help form. So it's pretty cool that you can chuck in some palladium metal, which looks red, brown, add it into your test, and it can carry out these amazing chemical transformations in one pot. So here's some pictures of where I work. This is a glove box. It kind of looks like a baby incubator, but inside of it is air-sensitive chemicals. So in there is a strictly nitrogen environment. So when you want to go in, you have to put your hands into the gloves, and they're full of baby powder because they get sweaty. And so you have to put your hands in there, and you have to weigh out things that you want. And when you want to take it out, there's something called an antechamber, and it's right here. And you put yourself in this antechamber, which is filled with nitrogen, and then you can walk around to the outside and you can take it out. And you can use it in air for a short amount of time. But there are a lot of pyrophoric things in there, so if you take them out into the air, they'll spontaneously burst into flames. So you have to be careful with what you want to take in and out of it. So you have to consult your boss. This is a hood, which you probably have in your lab. And this is my office. This is where I work. So a few things that are in my hood. I have an oil bath, which is on the far right, and you can see a few different test tubes in there. So the oil bath is great. I can set a reaction for, say, 95 degrees, and it will hold it at that temperature specifically, so that's a great thing. You can see that my test tubes have these long black tubes coming out of them. Those are nitrogen lines, so these have to be done under an inert atmosphere. I have a column here, this picture of a column, and we use columns to separate things and to make things more pure, and so you can have columns that separate things by size, so smaller things run down to the bottom and the big things get